Okay, this video is on polar symmetry. So there's three different conditions for polar symmetry. There's symmetry with respect to the polar axis, which traditionally, like if you look at a polar graph, it's going to look this axis here is the polar axis, and a typical coordinate plane, that would be the x-axis. And so for this particular condition, if you look at this graph down here, you can see that it is symmetric with respect to this axis right here. Okay, and you notice that when we're looking at the polar coordinates, we've got the point up here, which is r theta, and the symmetric point down here also has r, but it's at negative theta. So you can say that theta and negative theta both result in the same r. Okay. For example, if we use a particular example, we can use this function, r equals 4 cosine theta. If theta is pi over 3, which is approximately like where this point is right here, then cosine of pi over 3, we know from our special triangles in our unit circle, that cosine of pi over 3 is 1/2. Therefore, if we plug this in, we have r is equal to 4 times cosine of pi over 3, which is 1/2, which would be 2. Okay, now let's try plugging in negative theta. So if we do that, you can see that we have, if theta is negative pi over 3, cosine of negative pi over 3 is still 1/2. Like here, this is still, the cosine of that would be 1/2. And so if we plug that in, 4 times 1/2 is 2. So you can see that both cases, r cosine of theta with theta being positive or with theta being negative, both result in the same r. You can also notice that the function is symmetric about the polar axis by graphing the function and looking to see if it's symmetrical. So if you graph the function, r is equal to 4 cosine theta, down here, you can see that this is the graph that results. Okay, now if we change the theta to negative theta, here we have negative theta, it's the same thing. Okay, so that concludes the first test of symmetry with respect to the polar axis. Now the next one is symmetry with respect to the line theta equals pi over 2. That's this line. So when something's symmetric to the line theta equals pi over 2, the condition here, you can see that this point P and this point Q are symmetric about that line. So, and you can see that here, theta, and over here, this is going to be, you can look at this from here all the way over to here is pi. And so this right here is going to be theta. So this value, let me change colors, here is just pi minus theta. Okay? So if you can plug in theta, if you can plug in pi minus theta for theta and get the same r, then you know that you have symmetry with respect to that line. So an example for that is r is equal to 4 sine theta. If we say theta is equal to pi over 6, it could be any point, but this one's an easy one because we know the answer. When theta is equal to pi over 6, then we know that sine of theta from the unit circle is 1/2. And therefore r is equal to 4 times 1/2, which is 2. Now if we try the test, we have pi minus theta. Pi minus theta is 5 pi over 6. And you know that sine of 5 pi over 6 is 1/2 from the unit circle. And so therefore we have 4 times this, which is 1/2, equals 2. So whether you put in theta or pi minus theta, you get the same answer of 2. You can also look at the graph, and here you can see that this graph, which is 4 sine theta, is symmetric about the pi over 2 line. And here I have 4 sine pi minus theta, and you can see that this graph is identical to this graph. Now you can see here I tried plugging in negative theta, which was our test for symmetry around the polar axis, right? That was our test up here. When I tried that for this function, I said 4 sine of negative theta. When you plug that in, it looks like this. And you can see that this, although it's symmetric, you can see that this is not the same function as this. Okay? The third test for symmetry is symmetry with respect to the pole, this being the pole. And so you can see here that Q is symmetric relative to P relative to the pole. And a test for that, here we have pi, and here we have, here we have theta, I spoke, and here we have pi, right? And so this, because of opposite angles, is also theta. So here, you have r and theta plus pi and r and theta. So you can replace theta plus pi for theta, and you should get the same r. Another test you can do, so I'm going to erase this, and you can see that, highlight this, that this condition is interchangeable with that. Another way you could look at it is you could say, okay, well, instead of replacing the theta for pi plus theta, we could replace negative r for r. Because here, if you go to theta, right, and you can get positive r or negative r, that could work as well. Okay, so I'm going to send you a video as well, a separate video that has some example problems. And so watch that and work through that as well.